Hello and welcome to my Retro Computers repair workshop. Today I'm going to talk about a power supply unit and what is the best choice for a repair workshop like mine's. Obviously, there is no perfect solution, but it is very much possible to find something what matches the requirements the best way. Which requirements do we have? Take a look at this mainboard. It uses an AT form factor, which is the predecessor of today's ATX. This is a corresponding AT power supply unit with connectors which are very different from ATX. Such AT power supply units were used from the very beginning for the most PCs from 8086 up to Pentium. Even some Pentium 2 mainboards still being using AT form factor and AT power supply units. Mid of 90s, there were some hybrid mainboards which were made in AT form factor but had both connectors for AT and ATX power supply units. Later, even more ATX standards were released and they brought different types of connectors and power requirements. In my workshop, I'm testing and repairing all kind of retro hardware, and I have to switch the power supply unit every time I'm going to work with a mainboard from another generation. That makes me mad sometimes. So I decided to make something more versatile and create one setup which I could use with different generations of hardware, AT, ATX, whatsoever. The good thing is that ATX power supply can in theory deliver at least the same voltages as the old AT power supply. Why in theory, you may ask? Well, first ATX power supplies were designed to do so. But due to changing requirements, modern power supplies can lack some requirements we need for the retro machines. I'll come back to it later, and for now, let's take a look at the pinout of AT and the ATX power supplies. As you can see, we need plus minus 5 volts, plus minus 12 volts, ground rail, and so-called power OK line, which gives 5 volts to indicate stable voltages by the power supply. And on the right side, among the others, you can find all these rails in the ATX port connector as well. The colors of the cables can vary, but these are the usual colors you can find on the most power supplies. As you can see, the color coding remained almost unchanged from AT to ATX, except the power OK, which usually was orange on the AT power supplies back in the days, and is gray on the modern ATX power supplies today. Okay, let's create a simple ATX to AT cable adapter first. The required AT cables will be gracefully donated by an old and broken AT PSU in my scrap. The ATX power connector can be desoldered from one of the defective ATX mainboards. Soldering all the cables together shouldn't be a problem. However, don't be fooled by the cable colors and double check that you solder the cables to the right pins, or say goodbye to everything you'll connect to the power supply later. As I soldered the cables, first I forgot that orange cable of the AT power supply, which means power OK signal, must be connected to the gray pin of the ATX connector, and soldered it to the orange ATX pin, which means 3.3 volts. This wouldn't nearly be as deadly as mixing 5 volts and 12 volts rails, but still very stupid. One additional thing we have to take care of is the power switch. On the old AT power supplies, the power switch was a high voltage switch going directly from the power supply to the front panel of the PC. It literally connected high voltage cables together and gave power to the power supply unit. Not only was it dangerous for the user, it also prevented all possibilities of software control shutdown, which we got used to since the introduction of the ATX in the mid-90s. Do you remember this image? The reason for it was that the PC couldn't control its power shutdown with an AT power supply due to a physical switch. The ATX power supply units, on the other hand, have digitally controlled power switch. The power button on the front of the modern PC doesn't know anything about the power supply unit anymore. It is just connected to the pins on the mainboard, which controls the PSU to switch on or off. Unfortunately, old AT mainboards do not have such pins. They come from the times before ATX was introduced and cannot control the power supply unit. That's why we have to modify our ATX to AT adapter and add a physical switch which connects to the green power switch rail to the ground. As long as the green rail is grounded, the power supply will stay on, and we don't have to mess around with high voltage anymore. I removed the unneeded pins for safety reasons. Unfortunately, the ATX pins on the adapter tend to slide out when trying to push the connector, but I am sure there is nothing you couldn't fix with a lot of hot glue. Perfect! We have an ATX to AT adapter and can power any AT mainboard. Now it's time to choose an ATX power supply which fits our needs. As I told before, requirements on the power supply units changed in the past, and not every modern power supply would work for my use cases. First, most of the modern ATX PSUs don't support -5 volts anymore, since it's not needed by modern PCs and was made optional in ATX version 1.2. However, 30 years ago it was quite common. As an example, this 8-bit Creative Sound Blaster 2.0 sound card. It was very common in the early 90s, and this card needs -5 volt rail to work. Another issue about modern ATX PSUs could be the power of the +5 volt rail. Modern PCs need the most power on 12 volts rail, leaving only about 50 watts on the 5 volt rail. However, retro PCs need as much as 100 to 150 watts on 5 volts to work properly. For universal power supply in a retro workshop, I advise to take something from the time of Pentium 4. It usually fulfills the requirements for the very old PCs and has some nice extras from a more modern times as well. I think I found what I needed with this 420 watts PSU made by Trust. I can use it to power both ATX1 and ATX2 mainboards since it has 24-pin power connector, which is also backwards compatible to ATX1 20-pin one. The power supply has two coolers, so it remains cool but loud. However, I prefer my workshop power supply to be loud, so I can hear it when it's running. It still has the 4-pin Molex connectors to power the old drives. It also has two 4-pin Berg connectors for 3.5-inch floppies, compact flash adapters, and so on. It has additional 4-pin CPU power supply cable, and it even has already SATA power supply cables. It is very universal indeed. Now let's see if we'll get enough power out of it. As you can see, we get 16 amps at 12 volts, means 192 watts. And it has 30 amps at 5 volts, means 150 watts, which is plenty of power for the older machines. But the 12-volt rail is a bit underpowered for the newer machines. However, this is sufficient for the hardware I am usually working with. And last but not least, this power supply supports -5 volts, which are very important for the really old stuff. So I guess I have here exactly what I need. I cleaned this power supply unit already and made some visual inspection. It seems to be in a very nice shape internally. Let's check the overall voltages. Everything seems to be in limits. Now, one very important thing we have to check for a workshop power supply is the shorts or overcurrent detection on all rails. When working with very old mainboards with leaking batteries and aged capacitors, short circuits are quite a common issue. Safety is very important, and I guess nobody wants to put everything on fire. So when any of the voltage rails will be shorted to the ground, the PSU should instantly switch off. Unfortunately, this is where things are getting bad. At plus 12 volts and 3.3 volts, this PSU has short circuit protection. However, there seems to be nothing on other rails. When I short plus minus 5 volts or minus 12 volts rails, this power supply doesn't turn off. This issue disqualifies given power supply completely, even if it's so universally usable. Well, this is quite a bummer. I've been searching for another PSU in my boxes and found another two ATX and three AT power supplies. Unfortunately, both ATX power supplies didn't have any short circuit protection on 5 rails either. And only one AT power supply did really have such protection on all rails. But I wanted to have an ATX power supply for this project. Long story short, I didn't find any, and will continue for now with the ATX PSU, which I have. However, I will keep my eyes open for a better ATX power supply or some sort of another solution, and so far the only fix I have is a fire extinguisher at hand, which you should always have in your workshop anyway, always nearby. So I connected the DIY ATX to AT adapter. Let's see if I soldered everything right and the voltages are all okay. Minus 12 volts, 12 volts, 5 volts, and power OK gives also 5 volts. The power switch works also just fine. I will fix the power supply on the wall right below the monitor, so I'll have more space on the table and I don't need to swap out the PSUs all the time anymore, so it can remain fixed on the wall. However, there is not enough space for the PSU under the monitor, therefore I have to move the VESA holder a little bit higher. And here it is. Let's give it a try. Worked just fine. Now I have my universal power supply, which should work for almost everything from 8088 up to modern times. I just can quickly add or remove the AT adapter dependent on the hardware generation and it's ready to go. At least as long as there are no shorts on plus minus 5 volts and 12 volt rails. That's why, as I already told, this can't be the final solution and I will take another look what I can do about it. And that's it from me for today. Please leave your likes, dislikes or comments below. I hope you enjoyed this video and would be glad to have you on my channel again. So far, thank you and goodbye.